Ready to dive into the quantum world. Today we're going to be exploring the work of Walther Gerlach.
Oh, yeah.
A German physicist who helped kind of unlock some of its biggest secrets.
Mm-hmm.
And our guide for this journey is an essay by Jorgo Schneepack.
Okay.
Called Walther Gerlach, Spin Experiment and Quantum Technology, which focuses on his famous experiment and its impact on quantum technology.
It's really amazing how Gerlach's work, especially the Stern-Gerlach experiment, went from this kind of abstract concept to like the foundation of technologies that are shaping our world today.
It's mind-boggling.
Yeah.
And before we get ahead of ourselves,
Right.
Can we rewind a bit, set the stage for us?
Sure.
What was the state of physics when Gerlach was doing his research in the early 1900s?
So picture this. Physicists were facing a crisis. Their classical theories,
The tried and true.
the tried and true, were failing to explain new discoveries about atoms and light. It was like they were trying to fit square pegs into round holes.
So the old physics playbook wasn't cutting it anymore.
Exactly. And then along comes Max Planck with his radical idea of energy, quanta.
Okay.
He proposed that energy isn't this smooth, continuous flow, but rather it comes in these discrete packets, like
Right.
tiny little bundles.
So instead of a flowing river, it's more like a series of stepping stones.
Perfect analogy.
Right.
And then Einstein comes along and solidifies this quantum revolution with his work on photons,
Right.
proving that light, which everyone thought was a wave, could also act as a particle.
Wow, that must have really shaken things up.
It did.
So where does Walther Gerlach fit into all of this? What was he like?
So born in 1889, Gerlach was really captivated by these mysteries of the atomic world. He teamed up with Otto Stern, another brilliant physicist, to tackle this question that was central to this emerging quantum theory. Does the spin of an electron, a theoretical concept at the time, actually exist?
So they were dealing with a pretty big unknown.
Yeah.
What was their approach to solving this mystery?
They devised a really ingenious experiment, now famously known as the Stern-Gerlach experiment, where they fired a beam of silver atoms through a specially designed magnetic field.
What were they expecting to see?
So they anticipated that the atoms would spread out evenly on a detector screen on the other side,
Okay,
kind of like scattering a handful of seeds across a field.
makes sense.
Yeah.
So what happened? Did they get their expected result?
Not quite. Instead of seeing this smooth, continuous spread, they observed something astonishing. The atoms landed in two distinct groups.
Wait, so it's as if the atoms were making a choice, either up or down.
Precisely.
Wow.
This unexpected outcome provided undeniable proof that the spin of electrons is quantized,
Okay.
meaning it exists in specific discrete states.
Mm.
Just like a light switch can only be on or off, an electron spin can only be up or down.
No dimmer switch.
The dimmer switch.
That's wild. What did this revolutionary result mean for the world of physics?
This sent shockwaves through the scientific community.
Yeah?
It provided concrete evidence for the strangeness of the quantum world and its rules, which were far weirder than anyone had imagined.
Okay, but what about practical implications? Was this just a theoretical breakthrough, or did it have real-world significance?
So this experiment laid the groundwork for key concepts in quantum mechanics, like Pauli's exclusion principle, which governs how electrons are arranged within atoms.
I vaguely remember hearing about that.
Yeah.
Remind me, why is Pauli's exclusion principle so important?
It's crucial for understanding how atoms behave and interact.
Okay.
Imagine you're trying to build a house.
Uh-huh.
You need to know how the bricks can be stacked and arranged to create this stable structure.
Right.
Pauli's exclusion principle does the same for atoms.
Okay, that makes sense. But how does this connect back to Gerlach's experiment?
Well, the Stern-Gerlach experiment demonstrated that electrons have this intrinsic property called spin, and Pauli's exclusion principle relies on that understanding to explain how electrons organize themselves within an atom.
So without understanding electron spin, we wouldn't have Pauli's exclusion principle, and without that...
Our world would be vastly different. Lasers, transistors, even modern chemistry. These wouldn't exist as we know them.
Whoa, talk about a domino effect.
I know, right?
So Gerlach's work, even though it seemed so focused on this tiny world of atoms, ended up having this huge ripple effect on technology.
Absolutely. And it doesn't stop there.
Oh.
We're just beginning to explore the possibilities of harnessing electron spin for even more groundbreaking technologies.
Ooh. Now you've got me really curious.
Yeah.
Before we dive into all of that, though,
Yeah.
I think a quick recap would be helpful.
Yeah.
We've covered a lot of ground in a short amount of time.
agree to quick recap to solidify these key concepts before moving on. Okay, so let's quickly kind of revisit what we've discovered about Walther Gerlach and his work.
Okay.
We're talking about a physicist working in the early 20th century when, classical physics was struggling to explain some fundamental things about the universe.
Yeah, it sounds like physicists at the time were a bit like explorers navigating uncharted waters.
Yeah.
Right? They need a new map to make sense of things.
Exactly. And that's where Gerlach, along with Otto Stern, made their mark, their experiment. The Stern-Gerlach experiment, which involved shooting silver atoms through this specially designed magnetic field, produced an unexpected result that changed everything. Instead of seeing those atoms spread out evenly, they landed in two distinct groups.
Right. They expected the atoms to scatter randomly.
Yeah.
But it was as if each atom consciously chose a path, up or down.
Yeah. It's really wild.
Yeah.
That observation led to the incredible discovery that spin, an intrinsic property of electrons, is quantized. It's not this continuous thing. It can only exist in specific states. Think of a light switch. It can only be on or off.
So no dimmer switch for electron spin.
No dimmer switch.
That's a pretty bizarre concept to wrap your head around.
It is, and that discovery opened up this whole new world of understanding, the quantum world.
Right.
A world where things behave in ways that completely defy our everyday experiences.
Yeah.
And that experiment, the Stern-Gerlach experiment, became a cornerstone of modern physics.
We talked about the ripple effects of this experiment, but I'm really curious to delve deeper into the world of quantum technology.
Okay.
And see exactly how Gerlach's work is influencing things.
Well, imagine a computer so powerful that it could perform calculations in minutes that would take classical computers billions of years to complete.
Okay, now you're talking science fiction. How is that even remotely possible?
It's the mind-boggling potential of quantum computers.
Okay.
They harness the bizarre rules of quantum mechanics to achieve computational power that's simply unimaginable with our current computers.
And Gerlach's work ties into this somehow.
Absolutely. Remember how the Stern-Gerlach experiment showed that electron spin exists in those specific up or down states?
Uh-huh.
Well, in quantum computers, those states are used as the building blocks of information, what we call qubits.
So instead of using ones and zeros like a regular computer,
Right.
a quantum computer uses the up or down spin of an electron.
That's the basic idea, but here's where it gets really fascinating.
Okay.
Because of the strangeness of quantum mechanics, these qubits can exist in a state called superposition, meaning they can be both up and down at the same time.
Hold on, they can be two opposite things simultaneously.
Yes.
How is that possible?
It's one of those things that makes the quantum world so mind-bending.
Yeah.
This ability to be in multiple states at once is the key to quantum computers' immense power. It allows them to perform a massive number of calculations in parallel.
Okay, I'm starting to see the potential here.
Yeah.
But what kind of problems could these quantum computers actually solve?
The possibilities are almost limitless and could revolutionize entire industries. We're talking about designing life-saving drugs, developing revolutionary new materials, cracking the toughest encryption codes, even modeling financial markets with incredible accuracy. Things that are simply impossible for even the most powerful classical computers.
Sounds like we're on the verge of a technological revolution unlike anything we've ever seen.
We are, but quantum computers are just one area where Gerlach's work is having a major impact.
Wow.
There's another fascinating field, spintronics, where his research is also playing a starring role.
Spintronics. We mentioned it earlier, but I need a refresher. What's the gist of it?
Imagine electronics that utilize the spin of electrons, not just their electrical charge, to process and store information.
So instead of relying on the flow of electrons like we do now,
Right.
we'd be relying on the way they spin.
Exactly. And harnessing that spin offers some incredible advantages. For one spin can be flipped much faster than it takes to move an electron, meaning devices could become exponentially faster. Plus, spintronics has the potential to be significantly more energy efficient than our current electronics.
Okay, now I'm seeing why people are so excited about it.
Yeah.
But what are some concrete examples of spintronic devices?
One really promising area is MRAM, or magnetoresistive random access memory.
Okay.
Think of it like a super fast, super efficient computer memory that doesn't lose data when the power is turned off. Imagine never having to wait for your computer to boot up again.
That would be a game changer for all kinds of devices, from smartphones to those massive data centers we hear so much about.
Yeah.
Are there other potential spintronic applications in the works?
Absolutely. Researchers are exploring spin-based transistors, logic devices, even lasers that use spin. The field is exploding with possibilities.
It's incredible to think that this one fundamental discovery about the nature of electrons has led to such groundbreaking advancements in technology.
It really is a testament to the power of basic research, of seeking knowledge for its own sake.
Yeah.
You never know what amazing discoveries and innovations might spring from seemingly simple questions.
Before we move on to Gerlach's legacy,
No.
I think it's helpful to pause here for a moment and recap what we've covered so far. From quantum computers to spintronics, it's been a whirlwind tour of the quantum world.
Agreed. A quick recap will ensure we're all on the same page before we delve into the lasting impact of Gerlach's work.
Right, so let's recap where we are in our deep dive into the work of Walther Gerlach. We've talked about his groundbreaking experiment with Otto Stern, which proved the existence of electron spin.
Right.
That discovery really opened up this quantum world. A world with rules that seem completely counterintuitive to like our everyday experiences.
Yeah, and we've seen how Gerlach's work went from this abstract concept to the foundation of mind-blowing technologies like quantum computers, which have the potential to revolutionize everything from medicine to material science. And then there's spintronics, which could lead to like a whole new era of electronics that are faster and more efficient than anything we have today.
Yeah, it's incredible to think that all of this stemmed from like one fundamental discovery about these tiny particles called electrons. It makes you really appreciate the power of scientific curiosity.
Absolutely.
But what about Gerlach himself?
Yeah.
What was his legacy beyond the Stern-Gerlach experiment? Did he continue to make groundbreaking discoveries?
So while the Stern-Gerlach experiment remains his most famous achievement, his impact extends far beyond that single experiment. Think of him as a pioneer who not only made this momentous discovery, but also inspired generations of physicists who came after him. His work helped solidify the field of quantum mechanics and encouraged other scientists to explore this strange and fascinating world.
So his legacy is about more than just one experiment. It's about shaping the entire scientific landscape.
Right.
It's about pushing the boundaries of what we know and encouraging others to do the same.
Exactly. The Stern-Gerlach experiment wasn't just some isolated event in scientific history. It's a cornerstone of modern physics, and it continues to be taught in classrooms around the world.
Yeah.
It's a classic example of how a simple, elegant experiment can completely change our understanding of the universe.
So Walther Gerlach's legacy is about more than just one experiment. It's about the ripple effects of that discovery.
Yeah.
The way it continues to inspire and inform scientific progress, even today. It really makes you wonder what he would think if he could see how far his work has reached and what the future holds for these quantum technologies.
I think he'd be amazed. And it's a reminder that the pursuit of knowledge, driven by curiosity and a willingness to challenge the status quo, can have a profound impact on the world. We owe a lot to scientists like Gerlach who dare to ask fundamental questions and pursue their curiosity wherever it might lead.
This deep dive into the work of Walther Gerlach has been fascinating. We journeyed from the early days of quantum mechanics to its incredible applications in fields like quantum computing and spintronics. And it all started with a simple question. Does the spin of an electron actually exist? A big thank you to Jorgo Schneppat for his insightful essay, Walther Gerlach. Spin experiment on quantum technology, which guided our exploration today.
It's amazing to think about all the possibilities that are still out there.
Yeah.
All the mysteries of the quantum world that are waiting to be uncovered.
It makes you wonder what groundbreaking technologies will emerge from those discoveries. That's it for our deep dive today. Keep those minds curious, and thanks for joining us.